Okay, we've done the experiment. We put our data into Minitab. Now what we want to do is understand what did Minitab actually have to say and what can we conclude about those comments. So we're going to analyze the experimental results. So let's take a look at how to do this in Minitab. Now that we've got the data into Minitab and we've gone and done our experiment, C10, the complaints column, is the data that we've recorded for each of those experimental points. So what we want to do is we would like to turn and say, how do we analyze the data now that we've got it in? So again, in Minitab, we go to Stat DOE, Factorial Design, and now we see we can analyze the factorial design. So we want to click on this box and say, okay, what can we do? So we can put the response in is complaints. Okay. Now, this is good. So we see there are a number of things that we should select. So terms. So what it's done is it's collected all of the terms that we can do in the analysis. So there is the 16 different analysis models that we can take a look at. So this is looking at A versus B, which is standard rate versus installer experience, A versus C, and then the three-way interactions and the four-way interactions. So that's good. Okay. And then we see the covariates. Well, we don't really have covariates. Under options, we can take a look, do we want to have weights and so forth? And the answer is no, and no, we don't want to transform the data, so we cancel the options. We're not going to do a stepwise regression. Graphs, this is about the different types of graphs. Now, what I'll do is I'll show you all three, okay, and then the residuals graph. So just like we had residuals analysis in ANOVA and in regression, we can also have residuals analysis here. And then results, we get to take a look at how do we want the results shown. So we want just simple tables, and that's fine. Okay. And we're not going to store anything. So this gives us then the analysis of the results. So here we see, okay, here's the Pareto chart for effects. Now, what this is saying is A and D are two main effects. So that's standard rate and service difference. Those are both statistically significant. So the 7.90 is the level for the p-value. Now, when we start showing this to management, we really don't want to show charts like this. Because, for instance, if I take a look, response is complaints. Okay. So if I take a look at this and I say, okay, response is complaints, what do I see about that? Well, I really don't like this complaints being here. Okay. Why? Because if I say response is complaints, what does management know about that? Okay, nothing. So we just zero that and get rid of it. Okay. This is a mathematical number, p-value. It changes based on the effects. Okay. So what I want to do is I want to edit that line label and say p-value equals 0.05. Okay. Get rid of my typo there. So now it's clearer to management. The terms are okay. Length PSE, management doesn't know what that is. Okay. View model used for graph. Okay. So I don't really want to do that, but let's just show. Okay. So Pareto analysis of, now instead of the effects, what I want to do is call this complaints. So I want to edit the Pareto chart of the effects and call it Pareto chart of complaints. Let's call it complaint factors. So now I see what's happening a little bit more clearly. And if I come here and I right click and then right click again, or click and excuse me, left click and left click again, and then right click, and then I can edit the bars, and I want to do custom again, and I like to put both crosshairs and also the color, and I'm going to choose blue this time, and so it's a lighter blue, shade of blue, and I'm going to do the same thing here and edit this bar and add the crosshairs. Why do I add the crosshairs? Well, because if I ever have a black and white graphic, then I can show this and I'll be able to see the difference. even if I don't get the right color separation. So edit the bars again, custom, and then coloring and automatic. So what I see is that those three are the ones I want to talk about. Those are statistically significant. So those are two main effects that are significant, and their interaction effect is significant. Now remember, many times if we have two strong main effects, that they will then create a strong interaction effect. Okay, so this is the first thing we've learned. So I'm going to move this chart off to the side. We'll probably come back to this. Now, that's the chart I want you to use. Here's a half normal chart of effects, and here's the normal chart of effects. I really don't want you to show these to management. Why? Even though I can explain what they are, it's probably not even worthwhile taking the time to do it for green belts, because it's actually just saying there are three significant effects, A, D, and AD, AD, AD. And what I really don't want to get into is trying to explain those charts to management. And so this chart is easy to explain to management. Pareto plots are something that you want your management to be able to be used to seeing. And so that's the type of chart we want to see. Do I want to save it in a separate file? No. And for those of you who are seeing when I do this and you see this strange language up here, this is Finnish, and that just A means no. So you won't see those on your charts, I'm sure. Okay, so what else can we do with this? Well, let's go up and take a look at what happened in the session window. So in the session window, I get my data. Okay, and it's coming, okay, here's residuals, the regression analysis. Now, so what I start seeing is, there's my data, there are the adjusted sum of squares and so forth. Now notice what happens. I have 15 degrees of freedom used in the analysis. And what happens is, I don't have any degrees of freedom. Remember, it's n minus 1 degrees of freedom I have to calculate. So there's nothing left over to calculate noise. And the p-value, or the f value, is calculated as the amount of the adjusted mean squares compared to the noise value. So if there's no factors for noise, I can't calculate it. So Minitab stops the analysis. Now, lest you panic, we already know that many of these factors are not important. So as a matter of fact, we know that A, D, and the AD interaction are the only ones that are mattering. So let's go back and let's go to Stat DOE, and we're going to go back to Factorial Design, okay? And we go back to Analyze the Factorial Design, and we see, yes, we want complaints, but let's go to Terms. So we want A, but I don't want B, okay? So I click this back arrow on B, I click this back arrow on C. I want D. I don't want, and I'm going to left click on AC, I don't want AB or AC interactions, and I don't need any of these other three-way, two-way, three-way, or the four-way interactions. So now what I've done is I've basically taken those out of the analysis effect and moved them into the noise. Okay, so if I click OK, and now I just click OK, I get the results. Ooh, now I'm going to, again, minimize these two because we're not going to use them. But there's the Pareto plot. Now I'm going to go back and say, let's take a look at this other Pareto plot that we had. This is the one I dressed up. So which one do you want to show to management? So these, it's saying the same thing as here, AD and AD and the AD interaction are all statistically significant. But I'm missing the comparison to all the rest. So this is the chart you want to show to management, not this one. So even though this is what our analysis is going to be based on, this one tells the story for management in a way that communicates more clearly. So that would be the chart that we would like to use. Okay? But now we've got the information. I can see the p-values, and I see what's statistically significant, and I can understand what those effects are, and I see that I'm actually explaining 97% of the variation. So wow, that's actually pretty interesting. Okay, so I can actually get from this information a very good understanding of what's happening in the different areas. Okay, so as I'm taking a look at this graph again, so we see this Pareto plot for complaints. Okay, so I say, okay, that's the news. Okay, now what else can we do in terms of analyzing this data? So let's go back to stat DOE analysis, factorial. So I could actually show a cube plot, factorial plots, and so I can take a look at the different factor plots. So let's look at those. So I have all of these factor plots, models and terms. I can take a look at the graphs. I can take a look at the main effects and the interaction plot. And so we're going to display that lower left matrix. I click OK. And here I get, okay, so here is the main effects. So there's the AD interaction. Okay, and here's the main effect. And what this says is, as the standard rate moves from 240 to 340, the number of complaints decreases. And here, as the rural goes to urban, the number of complaints increases. And here we see there's an interaction effect between the two. So these are some ideas about what's happening in that process that we now can see more clearly. So these are main effect and interaction plots that back up the Pareto plot. And this one we use for saying, how would we actually like to run this process? So if I want to run the process and I say, I would like to have, do I want to maximize complaints or minimize complaints? So I want to minimize complaints. So I would say, these would then be the factors that I would choose in terms of how I'm going to set this up. The other two factors, operator experience and travel distance, didn't seem to make a difference. Well, I'm sure you can see that there's a lot of information we can learn about the process, a lot of insight that we can be gaining, and there's even a lot more when we look at the more advanced aspects of design of experiments. And we can handle higher levels of factors, more than just 2 factors at a time or 4 factors at a time. We can handle 7, 9 factors at a time. And the simplifications that we make and the complications that arise out of those simplifications creates a very complex situation for us to deal with in the planning of the experiments, as well as in the applications of Minitab. So before you take a look at going into those types of experimental processes, what I recommend is study more about DOE. It takes a couple of weeks to really understand how to actually do these more complex designs in Minitab, how to apply them, and then how to think through that process of actually making them work the best for you to discover what are the secrets that are hidden in your process. So now what we'll do is we'll turn to the final of the improvement opportunities that we have, and that's the process of benchmarking.